Hello and welcome to another maths video. Today we're going to be solving the very difficult equation of bx plus c, where we're solving for x. Now, linear equations are one of the most tough equations to solve, and to do this we're going to have to come up with quite an interesting approach. We're going to consider a different equation, ax squared plus bx plus c equals 0. This is a quadratic equation. These are of course easy to solve. We just use the quadratic formula. And when a equals 0, the solution of this equation will be the same as the solution of this equation. And so to illustrate that with a graph, if we draw some axes on, x and y, and we draw y equals bx plus c here, and y equals ax squared plus bx plus c here, it would look something like this. And if we consider the same graph but for a smaller value of a, we would get this. And if we considered an even smaller value of a, it would look something like this. And as a approaches 0, one of the roots of the blue graph will get closer and closer to the root of the red graph. And so that is how we will be finding the solution to this linear equation. And so using the quadratic formula, we get that the solution to the blue equation of blue x would be equal to negative b, or the multiple solutions would be negative b plus or minus the square root of b squared minus 4ac divided by 2a. That much is trivial and well known. So as we take a approaches 0, then this will approach the value that is the solution to this linear equation. Now we have to be very careful here, because only one of the roots of the quadratic graph will approach the solution of the linear graph. And since we're specifying b greater than 0 for this case, we'll cover negative b later, then the minus square root of b squared minus 4ac will give some negative number on the numerator, and a being equal to 0 will be dividing a negative number by 0. Dividing by 0 doesn't make us happy, unlike a gay wedding, so we'll only be considering negative b plus the square root of b squared minus 4ac. And so that's the solution to our blue equation. The solution to the linear equation, red x, would be equal to the limit as a approaches 0 of blue x, and then if we just substitute in this quadratic formula, that gives us negative b plus the square root of b squared minus 4ac over 2a. Now, solving this limit is not exactly trivial, but it's quite easy if we use L'Hopital's rule. Because as a approaches 0, this numerator will just approach 0, and the denominator will approach 0, so we can use L'Hopital's rule to say that this will be the same as the limit of the derivative of the numerator over the derivative of the denominator. And so this will be equal to, well, we'll do the numerator first, differentiating with respect to a, the constant disappears. Differentiating this part with respect to a, by the chain rule we'll first have half b squared minus 4ac to the negative half. But then we also need to multiply by the derivative of what's inside, so that will be times minus 4c, divided by, well, the derivative of 2a with respect to a is, of course, 2. And so now the constant terms in here, half times 4 is 2, and then divided by 2, these all cancel, and we get 1 on the denominator. We can, oh, I think I might be running out of space on the blackboard, so I'm going to just rub some stuff out. Okay, so this is what we've rearranged our expression to. What I'm going to do now is bring this b squared minus 4ac to the negative half to the bottom of the fraction, and we get negative c over root b squared minus 4ac. Now we can just let a equal 0 in this expression, and we get that this term goes to 0. So this is just negative c over the square root of b squared, and since b is positive, this is just negative c on b. Therefore, our solution to the equation bx plus c equals 0, oh my god, that looks like child's handwriting, is x equals negative c on b. Now, at the moment we've only shown it for positive b, and we'll show it for negative b as a neat little corollary here. And I'll just rub this out and be back in a sec. Now let's suppose we want to solve the equation bx plus c equals 0 where b is less than 0. Well, we can just multiply this equation by negative 1 and we get negative bx minus c, or I suppose we could write plus negative c equals 0. And so then we could just let b dash equal negative b. Then we get b dash x, oh, and c dash equals negative c. b dash x plus c dash equals 0. Now, b is going to be positive because negative of a negative is positive. And so by our result we derived earlier, then x would be negative c dash on b dash, and this is equal to negative, well, c dash is negative c, b dash is negative b, these two negatives cancel out and we get negative c on b for b is less than 0 also. And for b equals 0, of course, the only solution, well, for c is not equal to 0, there is no solution. And for c is equal to 0, there are infinitely many solutions. And yeah, this concludes this video. Hope you learned something today. Hope you can finally solve this linear equation. And yeah, peace out. Oh.